Okay, now we're going to talk about specifically discontinuity, the four types, and then a quick refresher when there's not discontinuity. So again, when a function is continuous, it will not be discontinuous. There will not be discontinuity. So if you are asked to determine is the function discontinuous, and if so, tell us where. So you'd have to say where x is equal to a value, it's discontinuous. But remember, on a domain, so when you have a question like that and you see that it's a polynomial, x to some value, or a radical, I'll put it in there, you can just say continuous. And if you want to add, well, just put continuous, no discontinuity. So that would work. All right, so let me move. However, now let's start talking about the types of discontinuity. So the first type I'm going to introduce you to is removable, sometimes called point. I like point, but removable is a more visual way of describing it. And it is when, say you have a graph that looks like this, but there's one point that it can't be, and there's just a little hole right there. It almost looks as if that point was removed. So here would be an example. If you've got a polynomial, say x squared minus 6x plus 8, and down here you have x minus 2. This is a great example of point discontinuity. So this in the numerator factors to x minus 2, x minus 4, because negative 2 times negative 4 is positive 8. Negative 2 plus negative 4 is negative 6. But we have an x subtract 2. Look at, that's removed. Those completely cancel each other out or removed. And when that happens, now if you type this function right here into Desmos, it's going to look like the line, it's going to be a line and it continues. But if you hover over the point where x is equal to 2, so this wouldn't be that graph. This x squared is that graph. But when this is simplified, if you plug this into Desmos, it will just be this line with a hole right there. If you touch the height right there, it'll say 2, undefined. It won't show the picture of the, well, if you click on it, it'll show the picture of the hole, but it won't. Anyway, so removable is when you have a rational function and at least one or more of the factors cancel. And instead of having an asymptote, you just have a hole. That is removable. And then the answer to your question would be, if you're, you would say removable where you always have to add where x is equal, in this case 2. But whatever zeroes out the denominator, that's where the removable point will be if it's been canceled. So you say where x is equal to 2, removable discontinuity or point discontinuity. All right, the next type of discontinuity is jump. Well, I don't know why I'm doing it this way. I'm sorry. So removable looks just like this. If you've got this original function, notice that x squared minus 1 over x minus 1 factors, this is a difference of squares, x minus 1, x plus 1, those cancel. And now when you substitute 1 into this, you have the height of 2. And if you look at the graph, over here I plugged in this graph into Desmos, and when I touched this point right here on Desmos, it showed that there is a hole that appears. And that right there, so if this were a test question or a homework assignment, you would say, and it's asking, is this continuous or discontinuous? And if so, what type of discontinuity? You would say removable, or you could say point. And spell it all out, discontinuous. discontinuity. This is the important part, where x, in this case, where x is equal to 1, there's removable or point, and I'm okay with whichever one you choose. You have to talk with, if you're at a different school, talk with your professor which one he or she approves. All right, now we're going to go on to jump discontinuity. So think about the word jump, where you're standing and then all of a sudden you jump, and now maybe your feet are up here, and in between there's this huge gap. Your feet were here. I'm a really horrible artist. When you jump, now your feet are here. Well, there's this big gap. See, basketball players do it all the time. Or there's a vertical leap. Well, that's what jump or step discontinuity is called. So there's a couple of different types I'm going to show you. We'll go into more depth to this later, but the graph of this rational, keyword is rational, absolute value graph, where you've got an absolute value function over itself, or maybe you would have a function over itself and in the denominator there would be absolute value. It produces a graph that looks like this. They go in two separate directions, and then it leaves this big gap, and that's the c or the x value. So you would say, if you see a graph that looks like this and it's asking about discontinuity, you would say this is jump, or you could say step, jump discontinuity, where x is equal to c. Oh, I already have that written down. Duh. All right, so then the next type, ooh, this video is going long, is when you have a piecewise. You're saying that the function, this one function, is broken up into two pieces. Well, then you have to graph both the pieces, and if you notice that there is a gap between those, whatever that c value is, and you'll know the c value because it'll be listed right over here, whatever that c value is, you would say jump discontinuity, where, and if you're not putting where x is equal, you will lose considerable amount of points on an exam. So be very careful, because this is a really important piece of understanding discontinuity. It's only discontinuous here. If we look at the graph here, it's fully continuous. If we look at the graph over here, fully continuous. But where x is equal, in this case c, there's a jump discontinuity. All right, then we have what's called infinite. I like to refer to it as infinite, but I think there might be a lot of college professors that refer to it as essential. So if you're going into engineering or computer science or science, just make sure you talk to your professors which they prefer. So infinite discontinuity is when you have a rational function, and when the denominator zeroes out, you're left with an asymptote. And then notice, so this graph goes like this graph goes like this, and where x is equal to c right there, these two things don't agree, and they're both headed towards infinity on both sides of that asymptote. So here's the asymptote. The graph on each side of that asymptote is headed towards infinity. So this is a specific type of infinite discontinuity, or essential discontinuity, where in this case, well, again, x is equal to c. Oftentimes it'll be where x is equal to 0 because there'll be an asymptote on the y-axis. But regardless, this is infinite discontinuity, and it can look like that, or it can be irrational where it's 1 over x squared, or 1 over x to the fourth, or just 1 over x to the even. where both sides of the asymptote are headed to the same infinity, that's still going to be a type of infinite or essential discontinuity. Again, the key part is where x is equal to whatever c value. In this case, this is 0. So where x is equal to 0, it is essential discontinuity or infinite discontinuity. One more. Oh, this is long. Oscillating discontinuity is when what we're going to be doing is trig functions. And when you see sine and in parentheses, whoa, sorry about that, you've got this phrase. It could be 1 over x, or in this case, we have 1 over x subtract pi. The graph of that is going to look, put it into Desmos to check it out. It just starts reverberating right here, and it just keeps going, the echoing and echoing or reverberating, and it's reverberating so fast that you can't stop it long enough to get a height. That is called oscillating discontinuity. In this case, whatever zeroes out the denominator, in this case positive pi, where x is equal to pi, we have oscillating discontinuity. All right, those are the 4 types of discontinuity.